Good afternoon, everybody, and welcome. Now, I will say to start with that I have changed the title of this presentation from the publicized one, which was the old JDK 12, Pitfalls for the Unwary, to the much more modern and up-to-date JDK 13, Pitfalls for the Unwary. As we'll see, it actually doesn't make a huge amount of difference to the presentation, but there you go. Now, the idea behind this presentation is to gather together absolutely everything that might have an impact on migrating an application from JDK 8 or earlier to JDK 9 or later. So I always like to start these presentations by a quick survey of the audience. So who here is using JDK 8? Right. Who here is using JDK 11? Okay, a few. Oh, good. Okay, a few people. Anybody using 9 or 10? Okay, good. That is what I like to see. So we're going either 8 or 11. Actually, anybody using 7? 6? Oh, okay, a couple of people. Right. So, important thing, JDK 9. So let's go back 2 years to when JDK 9 came out. That seems incredible to think that JDK 9 came out 2 years ago, and now we're on JDK 13. But that's the new release cadence. And JDK 9 is quite important. I borrowed this slide from Oracle. I used to work for them, so I figure that they owe me a slide or two. And it lists all of the features that went into JDK 9. And there's about, I think, 86 if you count them all up. But Oracle were quite clear that JDK 9 was going to be the last major release of Java. And what they mean by that is the last release that had multiple years of development effort in it. As we've seen, we've moved to a 6-month release cadence, so we've had JDK 10, 11, 12, 13 now, and obviously we'll continue with that. But that's quite important, and JDK 9 also had some other significant changes. And the significant changes was around the fact that with Java being, at that point, somewhere around 22, 23 years old, lots of new features had been added over time to Java. And that's great because now we have lots of new classes that we can use. We don't have to write all our own, things like that. But it had built up an enormous amount of technical debt for Oracle as the people who look after Java. So they decided with JDK 9 that in addition to adding new things, they were going to start cleaning up. And they were going to start deprecating more things. They were going to start removing things. And that's a big change because up until JDK 9, nothing had really been removed from Java ever. So that's kind of what we're dealing with. OK, so if we want to move an application from JDK 8 forward, and as most of you are using 11 at the moment, you're going to have to deal with everything that's in JDK 9 as well. Like I say, in terms of compatibility, we've always been used to Java code that was written on older versions running on newer versions. You can literally take JDK 1.2 code that was compiled on 1.2, and you can run it on JDK 8 JVM, and it'll work quite happily. You if you try and go back further than that, 1.1 or 1.0, there were some changes to the class file format, and that sort of did break things. But certainly you can run some 1.1 code if it's the right type of code. There were some minor issues, JDK 1.4, JDK 5, the introduction of assertions in JDK 1.4, the introduction of enumerations in JDK 5. That added some new keywords, which obviously broke backwards compatibility if you had used assert as a variable name or enum as a variable name. I remember doing JDK 5 talks and saying, nobody would ever use enum as a variable name. And then I compiled some of my own code and found that I had used enum as a variable name. But anyway, deprecation has been with us for a long time. Deprecation was introduced way back in JDK 1.1. And as I said, lots of things have been deprecated. I actually went through and counted in JDK 8. There are 492 API elements that have been deprecated in the core class libraries as of JDK 8, and none of them had ever been removed, which sort of begs the question of what's the point of deprecation if you don't actually remove anything. I suppose it gives you a warning about the fact you might want to use something else. Oracle have said from now on, they will give us a very generous minimum of 1 release warning between something being deprecated and being removed. Obviously, if it was less than that, it'd be no warning at all. But the point is that with the new release cadence, it means it could be only 6 months between a feature being deprecated and a feature being removed. So as I said, JDK 9 started this overdue cleanup of the Java platform, and they started removing not just methods and classes, but also features like some tools were deleted and various things like that. And this process is going to continue. So there are things like the concurrent mark sweep collector that is deprecated, and that will be removed at some point in the future. Nashorn has been deprecated. That will be removed at some point in the future. And so if you ask Mark Reinhold, he will give you this very reassuring statement about moving an application. He says, if your code only uses standard Java SE APIs, then it will most likely work without change. Personally, I'd like to see it will work without change, but because of the fact that we're removing things as well as adding them, then yes, it is most likely that they will work without change. Certainly, if you look at the things that we're going to discuss in the rest of the presentation, a lot of them are very esoteric and very unlikely to have been used in most mainstream application development. So I think this is, it's a fair statement, but most applications will work without any problem. Okay, so let's talk a little bit about the module system, because that is one of the things which does have a big impact when you're migrating applications from JDK 8 to later versions of Java. So don't want to spend too long talking about the basics of the module system, but it's worth just making a couple of points about this. The basics of modularity were really two different things. So the first part was saying that we have rt.jar, and it's very big and contains all the classes that we need. If you go all the way back to JDK 1.0, there were 211 public classes that you could use to write applications. JDK 8 has about 4,500. Which is great for us because it means we don't have to write a semaphore class, we don't have to write an array list class, they're all there for us. But having them all in one monolithic library is really not very flexible. And I think this is a great sort of challenge for the Java community, is to find somebody who could write a Java application that uses all 4,500 classes in that application. I think it'd be very difficult, but the reality is you don't do that. So what we really need is a way of dividing up rt.jar into more manageable modules so that when we need to build a runtime for our application, we can select just the ones we need. And we don't have to have all the other things that we're not using there. So what they did was they essentially broke it up into 75 OpenJDK modules. And of those, there's 24 that make up Java SE. That's what you need to comply with the specification. It's what you need in order to call something Java. There are two aggregator modules, and an aggregator module is one that doesn't contain any packages. It only contains references to other modules. And then there's this smart card module that kind of just got left in there from the good old days of when Sun, at the time, were sort of adding more and more APIs to the rt.jar, and they decided to put the smart card APIs into Java SE, which was probably not the best decision. And then there's 48 that is JDK specific that cover all sorts of different things like the Nashorn and the tooling and so on. Oracle JDK has more than that, so you've got another 14 JDK ones. There's 8 for JavaFX, and there's 2 that are Oracle specific. The other part of modularity was around the idea of encapsulating private APIs, because rt.jar, 4,500 public ones, but then there's a whole set of classes which are used to make the public ones work, and these are the ones that you're not supposed to use. So the most famous of these is sun, misc, unsafe. So a quick show of hands, who here has used sun, misc, unsafe in their code? Okay, so there's a couple of people there. Okay, anybody used a third-party library or framework like Spring, Log4j, Hibernate, anything like that? Yes. Okay, so you have used sun, misc, unsafe, you just don't know about it explicitly. And what Oracle wanted to do was to turn off access to all of these internal APIs, to hide them, encapsulate them. Reason being that they thought that this would give them less problems in terms of security, in terms of stability, and so on. But that didn't work out because too many people had used them to get better performance and to be able to do things that sort of a little bit outside of the normal Java way of doing things. So you can use them, but you need some extra command line options, and that's kind of the key thing. So how do you migrate an application from using the JDK 8 way of doing things to the JDK 9 and later way of doing things? Well, essentially, what you've got with JDK 9 and later is a class path, which is what we're used to. So that's where the JVM is going to look for the classes that it needs to run your application. So it will resolve things on the class path. And you can put those into jar files, so you've got archives. But in JDK 9, we now have a module path, which is, again, where the JVM is going to look to resolve when it needs a specific module. If we want to migrate our application, the simplest approach is to simply ignore the module path. So we leave everything on the class path, just as we have done before, all our jar files, all our class files, and run the application with the same startup parameters that we did before. And that will work because it's designed that way. The way it works is by saying that everything that's on the class path, in order to integrate with the module system, becomes part of what's called the unnamed module. So the unnamed module contains everything on the class path. That has a dependency on everything which is on the module path. And that way, if you have things in the module path, then automatically the jar files will be able to resolve against things on the module path. And because the rt.jar has been broken up into modules, it will be able to find things like string and integer and so on. So that all kind of works very nicely. So we can start off simply by leaving everything on the class path. If we then want to start migrating to using the module system properly, we can do that in two phases. The first phase is we can take a jar file that we have, and we can simply move it from the class path to the module path. We don't have to make any changes to that jar file, so we don't have to add this module info.class file to it to give it explicit information about that module. What happens then is that the module system will treat it as an automatic module. And an automatic module is one where the name of the module is derived from the name of the jar file. All packages, public packages in that jar file will be exported, and all the dependencies it has will be on all other jar files on the module path. So you're not specifying anything explicitly, so it just says, OK, automatic module depends on everything else, exports everything it has, but it still works. And then if we want to take it to the next step, we could rebuild our jar file, include a module info.class in there, which would explicitly state the name of it. You could put, I only want to export these packages, I only want to have a dependency on these modules, and so on. You can make it much more fine-grained. But that's the sort of three phases you go through. You either leave everything on the class path, move jar files directly to the module path and treat them as automatic modules, or you rebuild your jar file with module information. Now, encapsulation, as I said, was a goal of the module system, but it had to be reversed at the end because people needed access to these internal APIs. So they introduced this wonderfully named big kill switch. I think any command line flag that's called the big kill switch is a great idea. And the flag is illegal access. Again, a great name for a flag, illegal access. Now that has 4 parameters that you can specify with it, only one of which at a time. By default, at the moment, the value for illegal access will be permit, which means that you have access to the internal APIs in exactly the way that you need to. And when you first use a particular API that is internal, you will get a warning printed on the console. If you need more information, you can turn that up a level, and you can say, give me warnings. And that will give you a warning every time you use an encapsulated API. And that will tell you, how many times you're using those things. If you need even more information, then you can turn it up to debug, and debug will not just give you a warning every time you use an API, it will also give you a stack trace. And that way you can trace back, and you can find out where you're using these APIs. So if you want to make changes, it helps you in terms of doing that. And then the last parameter for this is deny, which is what they're hoping to turn on at some point in the future, but it's very unclear when or even if that's going to happen. But the idea is that you turn off access to encapsulated APIs, and then if you try and use them, you won't be able to. Now, if you don't want to do that in quite such a global way, there's also a fine-grained way of enabling access to certain things. Now, you can do this through one of 2 options. There's either add exports or add opens. Add exports will allow you to access an internal API through importing it and then referencing it from your code. And you can do that either, you can use add exports here, and you can specify the module that you're interested in, java.management, and then you can specify the package, in this case, ComSun JMX remote internal, and you can limit the access only to a particular module, so my test. Or if you want everybody to have access to it, then you can say all unnamed, and then everything on the class path will have access to those internal APIs. If you want to have access through reflection, then you use add opens. And again, the syntax of that is the same. So you say add opens, the name of the module that you want to get access to, java.base, and then the name of the package that you want to be able to access reflectively, in this case, java.util, and everything on the class path will have reflective access to that module. You can also, if you want to put this into a jar file, do it so that it's invisible. This is quite a nice idea, because if you're creating a library and you want to give that to somebody else to use in their code, rather than telling them, well, you have to turn on these options on the command line, you basically bake that into the manifest of the jar file, and you can say add exports, java.base, Sun security provider, and that will do the same thing as if you'd done it on the command line, but you don't have to do it explicitly. So it's a nice sort of tidy way if you are providing a jar file to somebody else. JDEPs is a very useful tool because this will help you to find the dependencies that your application has on modules in the system. So what you can do here is you can say, okay, JDEPs, you tell it where the modules exist, so you tell it where to look for the modules. Then you say which modules you're interested in processing, and then there's various arguments you can give it in terms of the information that you want to get from that. So in this case, I want to list the dependencies, and I've got a jar file that I created called flight tracker. And then it will print something like this. And it'll give you all sorts of information about the modules that you're depending on. So Java base, Java data transfer. It's kind of interesting the way that in the case of desktop, it sort of breaks it out into specific packages, but it doesn't do that for everything. I haven't quite figured out why it does that. But it says desktop, okay, there's these various packages that it uses, Java logging, scripting, SQL, XML, and then some JDK modules as well. But that helps you because now you understand which modules you're going to be using. And one of the other advantages of the module system is the fact that you can build a runtime which is tailored specifically to your application. To do that, you can use the JLink command. And if you use JLink with a fully module application, then it just processes everything automatically. But if you want to leave everything on the class path and still build a runtime for your application, then you use JDEPs, figure out which modules you need, and then provide that as a list to JLink so it creates the runtime only with these particular modules in them. So it's a very useful tool in terms of understanding what dependence you have on different packages and modules. Oh, that's the module that you want to process. So in the case of, so what am I actually, oh, sorry, no. Because I use JavaFX in this, so I'm using something beyond what is in the JDK. So I need to tell it, to look at the JavaFX things as well. Okay? Missing modules. Yeah, so if your code only uses Java SE APIs, this is the important thing. In JDK 9, the Java SE.EE aggregator module was effectively turned off. And this means that if you compile against any of the packages which are in the modules referenced by Java SE.EE, then when you compile, you will get errors because it won't be able to resolve those packages and resolve the classes you need. Similarly, if you try and run an application which uses packages from those modules, you'll get a runtime error because it won't be able to resolve those things. In terms of the things that are affected, there are 6 modules. First of those is Corba. Anybody here using Corba? Oh, one person. Okay, you're out of luck. Corba is one of those things that's been around for a long time. I'm not aware of anybody doing new development using Corba, but there may be people out there. But it has been decided that Corba is going away from the base JDK. So Corba goes away, transaction is also related to Corba. Beans activation framework, again, I don't find many people who are using that. XML bind is JAX-B, so the binding between XML and Java objects. Anybody using JAX-B? Oh, right, okay, yes, so a few people there. And then the one that does seem to catch out a reasonable number of people is JAX-WS, so the web services using SOAP-based messaging and WSDL. Anybody using that? Yes, probably the same people using JAX-B. And all those things go away in terms of direct access for JDK 9 and JDK 10. So if you want to use those in the earlier versions, then you can still turn on, you can do add modules java.corba if you want. You can modify your Maven file. So Maven Central has versions of these available, so you can get those. You can also go to the reference implementation on the JSR, and you can download it from there. There are various different ways of adding things back in. So it's not too difficult. The only one that's a little bit issue, unfortunately, is Corba, because there isn't a reference implementation through a JSR for that one. But Maven Central, I'm not sure if Maven Central has a Corba version, but it may do. And then there's various ways, as I say, you can do upgrade module path, or you can deploy them directly on the class path. It really just comes down to what you want to do. But it is something that may affect compatibility if you're using JAX-WS, JAX-B, or Corba. Small incompatibilities in JDK 9. So the first of those is a single underscore is now a keyword in Java, which means that if you were to try and use a single underscore as a variable name, it would get an error, as release 9 is a keyword and may not be used as an identifier. Who here has used a single underscore as a variable name? Good. Well, I did check, and it turns out that if you had used a single underscore as a variable name, that it's not a problem. You can still use 2 or more underscores as a variable name. Now, the reason that they did this is actually for future work, because they want to be able to use a single underscore as the parameter in a Lambda expression where you don't use the parameter in the body of the Lambda expression. So it sort of hides the parameter from that. So that was the reason for doing that. They finally removed some methods that had been deprecated. And what they ended up doing, there were 3 classes, each of which had 2 methods, add property change listener and remove property change listener. And so the total of 6 methods were removed from JDK 9's rt.jar. And you think to yourself, okay, that's a pretty kind of like easy start to removing things. And you also think, well, what did these 6 methods do that was so bad that they got picked for removal? And it turns out that when they divided up the modules of the rt.jar, there were some very odd relationships between different classes because, of course, people had evolved the API and gradually used all the things in the libraries. So in order to do a cleaner modularization, they had to remove these 6 particular methods. They also removed a few other things which are not part of the sort of standard of Java SE. So this is the Java Authentication and Authorization Service. So the COM Sun Security Auth callback dialog callback handler was removed. Anybody think they've used that? Probably not. It's kind of like a really stuck down there in the weeds kind of thing. That was deprecated in JDK 7, so if you were writing code and you had used it, you would have got a warning anyway. Another thing that they introduced was the idea of JDeprescan, and this is the idea of being able to look at your code to find out where you have used deprecated APIs. So it can do a static analysis on class files, jar files, and against the standard Java SE APIs, and then report back on what things you've used which have been deprecated so that you can say, okay, if I really want to clean my code up, go back, look at all these things, and change them to whatever needs to be changed to. So just a simple example, I created a kind of contrived application that used some deprecated things. So in this case, I've used RMI Security Manager, which is a class that's been deprecated. I've used some methods here, which you can see have been deprecated, so some swing stuff and some RMI stuff and so on. But it gives you an idea of what's actually going on in your application code. Now, I said I'm going to cover absolutely everything that might impact on your application. So if you write some sort of tool which relies on files in the JDK being in a particular place, then that's something that has changed as well. Because the file structure of the JDK used to be like this. We had a JDK, and then within that, we had a bin directory. Bin directory had the Java executable and had a few other things. We had a lib directory that had the tools.jar file, and then we had a separate subdirectory called JRE, the Java Runtime Environment. And that had a bin directory, which had a copy of the Java runtime in it. So you actually got 2 copies of Java for the price of 1. And then you had lib, which had rt.jar. In JDK 9 and later, that's been flattened out. So the distinction between the JDK and the JRE has disappeared. There is no idea specifically of a Java runtime as a separate subdirectory. As I said, the idea now with JDK 9 is to use JLink to build a specific runtime for your application. The way that looks now is you've got a bin directory which only has 1 copy of Java in it, so that's fine. You've got a conf directory where they put all the files that they need that might be changed by you for configuration, because they used to be spread around. And then you've got a lib directory and a jmods directory. So essentially, the JRE directory has disappeared, the tools.jar file and the rt.jar file have gone. So if you relied on those things in your application, then that will be something that needs to be changed. Version string format. The JMod contains the modules. So lib contains any native code, so DLLs or dynamic libraries and stuff like that, so the platform-specific code. And the JMods is a new directory which contains the modules, which are packaged not as jar files, but as JMod files. So there's a little bit of a subtle distinction there. Version string format. So again, if you rely on this for your application, so if you're building a tool and you're looking at the version string format for your application, then this has changed. So the version string format in Java has always been very confusing. And again, when I looked at this, it turns out that we've had almost as many version string formats as we've had versions of Java. And you end up with this very bizarre situation where if you download Java SE 8 update 131, for example, and you do Java minus version, it'll actually tell you it's version 1.8.0_131, which is a little bit confusing. And that dates all the way back to JDK 1.2, which is where they started calling it Java 2, but marketing intersected with engineering, and engineering said, no, we're not calling it Java 2, we're calling it Java 1.2. So marketing called it Java 2, engineering called it 1.2, and that kind of stuck. So you got 1.3, 1.4, 5, then you got 6, 7, 8, and so on. So a little bit confusing. Also, difficulty in terms of how many patches are in things. So does JDK Update 55 have more patches than JDK 60, or is it the other way around? Well, logically, you'd think Update 60 would have more. Turns out Update 55 has more. So now we have a version string format which is feature, interim, update, patch. This is great because now we have feature, which is the major number. That's 10, 11, 12. Then we have interim, which is always 0. Which kind of begs the question, well, if it's always 0, why do we have it? But that's good because it was reserved for future. Maybe at some point we want to have something other than 0. Update, which is clearly the update number, and even that's more logical now because if you look back at JDK 9, you had 901. What would be the second update to that? Well, you'd think it'd be 902. You'd be wrong. It's 904. 1, 4. And the reason for that is because they needed a gap in case they had to have an emergency patch between there. So now we have logical update numbering, and if there's an emergency patch, we've got another number we can use for that. So anyway, non-programmatic issues in JDK 9. The Java Network Launch Protocol, which is used by Java Web Start, was still available in JDK 9, and they changed it to using strict parsing of the configuration files. Essentially, that would only have an impact if you had done some rather lax syntax in your JNLP file, and it might not parse in JDK 9, whereas it would parse in JDK 8. One thing that I have kind of bumped into is the fact that because we're now using the module system, what's called the extension mechanism and the endorse standards override mechanisms have been removed. And this is really things that are used by like application servers where they want to load additional classes before the application starts. So you used to have the Java Home lib ext directory and lib endorse directory. Those have gone away. And if you use JNI, for example, often you put native code in the ext directory. If you try and do that in JDK 9, it will stop your JVM from starting. So you'll get an error message saying it couldn't create the Java virtual machine because the ext directory exists and it doesn't want that. So again, it's just something to be aware of. Lots of flags have been removed, and so this is just a list here. I won't go through these in detail, but these are flags which are ignored. This is fine because they removed a bunch of flags, and even though they've been removed, if you use them in your startup script, they'd just be ignored, and it doesn't matter. They also made a lot of changes based on the fact that they changed how logging works in the JDK. And so all these flags have changed from JDK 8 to JDK 9. A lot of these are not too important, but things like print GC. Lots of people use print GC details. That's now -x log :gc -x log :gc star. So what you should be doing is changing your startup scripts to use these rather than the older version ones. So again, in terms of the deprecated flags, you get two different types of warnings. So one will say, okay, print GC is deprecated, and it will use the right one for you. So that's nice because you don't have to do anything explicitly. Other ones will come up with things like create mini dump on crash was deprecated, likely be removed, use this one instead. So it gives you an alternative. And then the most important bit about this is there are 50 command line flags in JDK 8 that will actually stop your JVM from starting. So if you use one of these, then rather than just ignoring it, rather than saying it will use an alternative, it will actually say, no, I won't create your Java virtual machine, and it will stop. So that's where you do have to change your startup script. Things like print heap at GC, which that's a fairly common one I've seen people use, trace dynamic GC threads, things like that. JDK 10. What do we get in JDK 10 that would affect compatibility? Okay, so local variable type inference was the first thing. Now, in this case, var is a reserved type. And this is important because it means you can still do this. So you could do var equals value added reseller. That's good because we don't have to go and change all our code that may have used var as a variable name. But in the unlikely event that you have done this, which nobody here would have done, you can't now create a class called var with a lowercase v. Nobody would have done that because convention says you use an uppercase v. But in JDK 10, that will not work. So again, it's a very small thing that might potentially cause your code to not work. More deprecated things have been removed in JDK 10. So the in the JDK.security auth module, not the whole thing, but within that, there's the com/sun security auth package and policy file, Solaris things, X500 principal, those have all been removed. And then also in the security auth module package, there's the Solaris login module and the Solaris system. Anybody using Solaris? Okay, probably not a problem then. More deprecated things that are removed. Okay, in the Java Lang Security Manager, they removed a single field and then all these methods to do with class depth, class loader depth, current loaded class, get in check, in class loader. So far, I've not found anybody who's come and said, oh, we're using those, so that's really bad. In Java Lang Runtime, so a couple of bizarre, well, not bizarre, but very obsolete internationalization methods, they was removed. Get localized input stream, get localized output stream. Okay, great. Again, haven't found anybody that's had a problem with those. And then various miscellaneous things that were removed. So they decided to remove the Java H tool, which is used for JNI, where you create the headers with that. And now, rather than using a separate tool, you just use Java C with the -H flag, and that will do the same thing. And they removed the policy tool in JDK 10. Command line flags again, some sort of smaller things here. So -D32 and -D64 are no longer valid, so they won't work. And then there are 5 -X options that have been removed. So OSS, SQ no pause, optimize bound threads, and use alt sigs. And again, those will stop your virtual machine from starting up. And I kind of looked at these, and I know like bound threads, I understand that one, but SQ no pause, I could not find what that does. So I have no idea what it does. Probably not going to be a problem for people using that. Well, because nobody is going to be using it. Okay, JDK 11, which it seems that a fair number of people have migrated to. What things have we changed in JDK 11 that might affect us? So the big thing here is that we now have 2 distributions from Oracle of the JDK. So the first one is the Oracle JDK, and that's the one that they have provided through java.oracle.com and the one that we're all used to using for however long. That's now under a commercial license. So it means if you want to use the Oracle JDK 11, you need a Java SE subscription to deploy it into production. They have a second binary distribution, which is called the Oracle OpenJDK JDK, and I'm told you have to say it like that because OpenJDK is an adjective, not a noun. So it's the OpenJDK JDK. And that comes with a GPL v2 with Classpath exception license, so you can use it wherever you like for free. There's no problems with that. And the important thing about that is only updated for 6 months. There's no concept of long-term support for that JDK. What Oracle have done is eliminate all functional differences between what used to be, or what is the Oracle JDK and what is in the OpenJDK source code. And that means that some things have disappeared from the Oracle JDK. JavaFX has gone, so there's no longer modules for JavaFX. And that's not too much of a problem because there is an open JavaFX project under OpenJDK. You can get binaries of that. You can just add it in from either ourselves, Azul, or you can get them from, there's another company called Gluon. The browser plugin has gone away. Anybody using applets? Good, because they're dead. The applets have completely gone away now. And Java Web Start. Anybody using Java Web Start? Okay, a couple of people. So Java Web Start, yep, this will affect some people. There isn't a direct replacement for that in terms of there isn't an open source. They didn't open source Java Web Start, so there isn't a direct replacement. There's a thing called ICT Web that's a good alternative, but it's not quite a drop-in replacement. You might have to do a bit of work to make your Web Start applications work with it. We're providing a binary build of that if you're interested, so you can go to our website and get that for free. Just say that. Lots more tools have been removed from JDK 11 as a result of some of these features being removed. So the applet viewer went, JControl, all the Corba stuff disappeared, so the IDLJ, OrbD, and so on. Monitoring tools, things like the Java Mission Control, that's now a standalone package because they moved that out of the Oracle JDK. Things related to Java Web Services, so JAX-WS, SchemaGen, WSGen, and so on, and also the Java deployment tools were removed, Java Packager and Java WS. So all of those things have gone from JDK 11. They have removed more APIs. So the big thing here was that the aggregator module that they turned off in JDK 9 has now disappeared completely from JDK 11. You can't turn it back on. There's no way of using it. You have to deploy with your own set of modules that replace those things. Other things that have been removed here, you've got a list here. So there's various stuff to do with Security Manager. Interestingly, thread.destroy got removed, which is, we've finally seen classes, yes, a round of applause there. Finally seeing some of the thread classes, thread methods that were deprecated way back in 1.1. Destroy has been removed, and also stop has been removed, but be very careful, it's only the one that takes a throwable. There's another overloaded version which doesn't take a parameter, that's still there. I don't know why they did that. Why didn't they just remove all the deprecated ones? Because nobody should have been using them in the history of Java. A few other miscellaneous things that got removed from JDK 11. SNMP monitoring support, that was a separate module that Oracle provided as a sort of additional thing to the OpenJDK. The JVM management MIB got removed as well. On the desktop side of things, if you're using graphical applications, the T2K font rasterizer got removed. Again, if you're using that, relying on any of the functionality from that, it's gone. And quite interestingly and importantly, the Lucida fonts were removed. And these were put there as a set of cross-platform fonts, so you get the same look for fonts on all different machines. JDK is now relying entirely on fonts from the operating system. If you really want Lucida fonts, we actually can make them available from our website as part of our Zulu JDK, so there's a way of getting around that. And a bunch of security certificates were sorted out just to tidy things up. There were old ones that needed to be removed from the trust store, but because most of them were invalid, I don't think that'll be a problem either. JDK 12, okay, so JDK 12, not much changed. So only a few things were removed here. The security warning in ComSun AWT was removed. That's an internal API, not even used in the JDK, so that went. One of the things they're trying to get away with is finalization or finalized methods. So those were removed from file input stream, file output stream, zip file, inflator, deflator. So they all went. And then also the global root certificate was for GTE Cybertrust was removed from CA certs. And because they've moved up to the next version of Java, so you can no longer use Java C in JDK 11 to generate code for Java 6. Probably a good thing, actually, that. JDK 13, right, so this is where I've updated the slide deck with all this exciting new information. There's not much of it. There's nothing really to worry about in JDK 13. There's only 2 APIs that I could find which were removed. And those are both from the Java Lang runtime, trace instructions and trace method calls. And if you look at the definition of those since JDK 9, it actually says they do nothing. So probably not going to be a problem there. So they were deprecated in JDK 9, and so that's literally the only things I could find in JDK 13 that had been taken away. Just coming back to command line flags, I always like to kind of look at this in terms of numbers. So it's interesting to see how many flags were removed from different versions of the JDK. JDK 9 removed 82 -XX flags. The fact that they could remove 82 of them and pretty much nobody noticed shows you just how many -XX flags there are. I think there's about 780, well, there were. They added another 72 back in again, just to sort of make up for the fact they were removing 82. Let's add another 72. JDK 10, they removed 18, added 20, JDK 11, 16, 34. In JDK 12, they added a whole bunch, most of which were for Shenandoah, which is a different way of doing garbage collection. And JDK 13, again, quite a small change here. They only removed 6 flags and added 12. And there's a really good website here, Chris Who Codes, who does these nice little things of all the different flags. So just to conclude, migrating to JDK 11 or later. If you've got a simple application, chances are you can migrate it without any problem. You just need to make sure that you're working with the module system, leave things on the class path, forget about the module path to start with. You might need to make some changes to the command line flags you're using because, as I say, some of them will stop the JVM from starting. But if you're not using any sort of weird and wonderful ones, then even that might not be a problem. If you're using any of the internal APIs, either directly or through another third-party library or framework, then you might need to do some tweaking of the flags so that you get access to those things. There's the tools like JDepreScan and jdeps that will allow you to make some more choices about that. And as I said, there's a whole bunch of small, tiny things that might catch you out in terms of removed APIs and things like that. And yeah, oh, just one thing I will mention is we have what we call the Zulu Community Edition, since I work for Azul. This is our free build of the OpenJDK. We build it from the OpenJDK source code. We run the TCK on it, so we pass all the tests, which means that you know that it's going to work in the same way. We support lots of versions, so we go all the way back to JDK 7. We have 8, 9, 10, 11, 12, and actually I should have changed this slide as well, because we do have 13 as well, as of yesterday. We have wide platform support, 64-bit versions for Windows, Linux, and Mac, 32-bit versions if you're using older Windows XP or something on Windows and Linux, and we've also got ARM 32-bit versions as well. And if you want commercial support, we'll be very happy to sell that to you at a very reasonable price compared to other people in that market. And with that, thank you very much.